Week 31, Part 1. This is our introduction to current electricity. So before we get into the notes, let me just show you a super basic circuit. Okay, this is a battery right here. And if we were to get some wire and connect the wire, so here's the positive terminal of the battery, and that goes to one terminal of a little light bulb. And then we were to take wire from the negative terminal and attach it to the other terminal in the battery, all of a sudden, let there be light. So, this is an example of a simple circuit where we would have electrons that actually flow through the circuit, meaning this path that goes through the light bulb and through the wires and then back to the battery. So that's what a battery does. Okay, basic electric circuit. Let's see what the note. So we're dealing with three different quantities or things or concepts here. Voltage is the first thing, and you probably have some experience with plugging something into a wall socket. So a wall socket is typically 120 volts. The little batteries that we put into electronic devices and whatever, these are AA batteries, so those are 1.5 volts. A car battery that is used to start your engine, that is 12 volts. And oh, there's our car. So here's what a car battery looks like. Here's an image. And it's usually a lead acid battery. So there are these plates of, what do we have? Positive electrons, so lead dioxide. And in here there's going to be some acid actually floating around. So we can get into more of that, but this is the sort of looking inside a battery. It's basically reactions that happen between different metals that cause electrons to flow. That would be a good description of it. So, what do we know? For voltage, we could say a formula, so this is Ohm's law, and we'll talk about this more later, but this says voltage equals current times resistance, and the units for voltage, this is easy to remember, are just volts. So, excuse me, what is a volt? Well, voltage is defined as energy per charge. So 1 volt is 1 joule per coulomb. So 1 volt is 1 joule per coulomb. Whoops. And, whoops, what else do we have? Yes, so this is a little review. Charge is measured in coulombs and energy is measured in joules. Okay, so voltage you can think of as the push on the electrons through the circuit. So when you plug something into a wall socket, what it does, there are two openings here, sometimes three, one is for ground, but basically takes electrons and runs them through the toaster, whatever you just plugged in, and then back into the wall socket. So that's a little description of voltage. Okay, current. So current is defined as well, let's describe it as the flow of electrons. And the more definition is charge per time. So the units are going to be in coulombs per second. And here's a microscopic image of what a wire would look like. So within a wire there are metal atoms. Okay, so wire is usually, wire is metal, and there's going to be some plastic or something surrounding it, an insulator. But electrons are very free to move in metallic bonds. So these electrons are going to move in that direction, causing current to flow. So something like that. Let's look at 4 different wires. So here we have a thick wire that is short, and the most current would flow through this. So this has the least resistance, whereas a skinny wire that's long, there would be the least amount of current flowing through this. So this would have the highest resistance. So we'll talk a little more about this, but this has basically low resistance and high resistance. I like to think about a hallway with students. Imagine there's a top view, like a blueprint, and there's a gymnasium. And there's a bunch of students in the gymnasium, and all of a sudden there's this earthquake, and everyone's trying to run out of the gym. And if there's this little long hallway, right, everyone's going to get crowded in, and it's going to be really difficult for them to move in that direction. So that would be this type of situation. Whereas if we had this huge, short hallway like that, and then they're free to disperse outside, people could move very quickly, and that would be this situation. Okay, so that's a little bit about current. Let's take a look at the units. I think I mentioned this. So we say an ampere, or an amp, which is also just written as A, is a coulomb per second. So we could say amp is coulomb per second. And so we use I to represent current. I know that's weird, but that's the way it is. Current, and this is delta Q, so this is amount of charge. And this is per time. So charge per time, current, that's our definition. Let's proceed. Alright, so battery. You're familiar with batteries. Here's one of the original, well, let me show you the, here's the original. So it's basically just two different metals, so copper and zinc, with some kind of salt water, or they used brine way back in the day. And we can do this in class, and we'll use vinegar, I think. So it's just sort of some acidic or electrolyte solution that provides ions for charge. So copper and zinc have different electron affinities. What that means is that one is going to give up electrons, and one's going to take in electrons and cause electrons to flow through the circuit. They might actually flow the other way. I forget which has the greater electron affinity. So this is sort of historical piece, right? Way back in the day, Alessandro Volta created this and used it, attached the terminals to frog legs and made them move. But anyway, these are different stacks of different metals, and they're going to be separated by thin layers of some electrolyte, and so some voltage is created between these things, terminals. This is a look into a modern day battery where there's all these different layers, and these are basically thin layers of metal that react and cause electrons to flow. Don't take apart AA batteries at home, by the way. Okay, so I have mentioned this. The two metals involved in a battery have different electron affinities. This is one way of describing what a battery does, is it provides a constant voltage to push current through the circuit. Both of these are used as the symbol for batteries, so we're going to be drawing circuit diagrams, and this is how we can draw a battery. Hey, what's going on? Oh, there we go. Okay, battery. Excellent. And then our third quantity, so we talked about voltage and current, voltage being provided by a battery. The third thing we have to talk about is resistance, and so resistance is just as it sounds. As current flows through a circuit, it is the resistance that slows down that current, meaning provides some resistance or takes energy away from the electrons as it flows through a circuit. So this again is Ohm's law written in a different form, where resistance has been solved for. A resistance has units of ohms and has this cool upside down horseshoe, and we will be creating some circuits with resistors, and they look like this. They're pretty small, but the color coding has meaning, and tells us about the resistance of the resistor. And when we draw resistors in a schematic or a circuit diagram, it looks like this. So here's a complete circuit. So we have a battery, and the lines represent wires. Let's label this. So this would be a battery, and this would be a resistor, and the lines are just wires. So we make the assumption that wires have no resistance, and that all the resistance in a circuit comes from the resistor or resistors. And frequently for us this is going to be light bulbs that we create. But anyway, this is a complete circuit because electrons are allowed to flow. This would be an open circuit because, so this right here would be a switch. And you see the switch in this case is open, so no current flows. The wires are like the path that the electrons can take. And then one additional detail here, the long side is defined as the positive terminal of the battery, and the short side is defined as the negative, just when we draw it. So negative, negative and positive. Alright, and here's a little, I think I drew this on the other page, but just a basic circuit. Let's move that out of the way. So we have a battery, the side of the AA battery with the bump is the positive side, and the electrons flow this way and through the light bulb and back to the battery, causing the light bulb to light.